So, hi everyone, I'm Nripal Adhikary. I am the founder of Abari. It's an organization that I founded in 2006. It's a private organization. It's a social enterprise. So it's a environmentally and socially committed research and design firms that tries to take traditional material and put them in contemporary context. And we especially work with materials like bamboo and earth. That's our major materials. And we have about 15 permanent staff. They are architects, they're engineers, they're like admin people. And also we have a lot of carpenters, 20 carpenters, and about 50% of them are women. We do furniture as well. And we've worked, apart from Nepal, we've worked in India, Bhutan, Ethiopia, Kenya, Uganda, USA. We also have projects in Burma and Sri Lanka in pipeline. Okay, to start with, this is how we cross bridge in Nepal right at this moment. Right? And this is a picture from 2011. It's a metal wire that's connecting two rivers, and the kids they climb on it and they cross the river. It's very unsafe, and it's not an exception. This is not a rare photo. It's like people are still doing it. And you would imagine how they would have crossed, say, 100 years ago when they didn't even have a metal road, right? You'd be very surprised. They actually had a full-fledged bamboo bridge back then. This is a picture from 1895. You know, they had the bamboo with ropes and cane. So we had the tradition, but somehow because our trust in cement and steel and a lot of lobbying, that we've lost all the traditional skills. Yeah. Even if you go to the mountains, we have amazing vernacular architecture. Like if you go up in the mountains, there's a lot of stone, and they build these homes with stone and cement mortar. They've been building like this for hundreds of years. If you go in the plains in Tarai, there's amazing earthenwork, with adobe, and then they use beautiful pigments, like natural pigments to color their house. Or if there's a lot of bamboo, there's a beautiful house in Koshi where they weave bamboo and put a layer of fiber, and then these houses are born out of the context, and they solve their basic needs pretty well. It's really cool. It's in summer. It's very well insulated. Similar house like this in Manang, Mustang area, and adobe house in the mountain. One of the major reasons people don't want to live in earthen house is because they think it is high maintenance. Yeah, but in Nepal, it's considered maintenance is not considered as a chore. It's a ritual. For example, I've been documenting this house for over 4 years. So this is the house when it was first built. They had some really nice relief. And then when monsoon comes, it gets washed off. And then there's this festival of Chhat after Dasai. And they make this beautiful paint, on this house. And then again next year it washes off too. And then they change this paint again, it's a different color. And then, every year it's really beautiful manifestation of their creativity. When people are thinking of earthen bamboo, this is what they are thinking now, a shack, right? But the same material can be like this if you do it properly. It's about execution, it's about how you, it's about engineering. And, it's really interesting to see it in modern times. This is a pavilion in Shanghai Expo, World Expo. And in that expo, this is from I think, 2012 or something, there were many bamboo structures. This is by German, it's a German pavilion. There's Portuguese pavilion, it was also bamboo, Spanish was bamboo, Indian, Vietnamese, they were all bamboo. And it's really interesting because about 200 years ago, all these countries were using steel in the same expo to show that it's modern, it's like really strong. But now all these industrial countries are using bamboo in the expo, saying it's a future material. They believe, and rightly so, that it is a future steel. It's a natural steel. So what we did when we started this organization, our basic aim was to find a sustainable solution to concrete and steel, and a material that's good for people and for the environment. These were the two very important things. And we chose bamboo. Why bamboo? Because we have about 54 species of bamboo in Nepal because of our biological diversity, geographic diversity. We have areas as low as 60 meters and as high as Mount Everest, which is 8,800 meters. So we have tropical bamboo, which are found all the way to Thailand, Indonesia, to really alpine bamboo. And it is basically a grass, and it can grow up to 36 inches in a day, right? So it reaches its full height of, say, 40 feet in like few weeks, right? And it's stronger than wood, for sure. And some of the species are even compared to steel. It reaches its full strength between 3 to 5 years. So it's a really interesting plant. When it's young, you can eat it as bamboo shoots. And when it's old, you can use it as timber. And apart from its, and it's like a fruit, because after 5 years, if you do not use it, it will go bad. So it's like picking a fruit from a tree. You have to eat it, or else it will go bad. So if you harvest it between 3 to 5 years and treat it, it will last forever. But if you don't, it will go bad. So it's good to use it. And apart from its strength, it controls erosion. It grows in marginal land. There's a famous story in Japan that the first plant that grew after the Hiroshima bombing was bamboo, because it can grow in a really harsh condition, and it doesn't require much water. So what we do is we're trying to create a whole supply chain of bamboo. We do not want to just use it because now in Nepal, bamboo is only used as temporary material. People only use it to make cow sheds or. So what we do is we work with farmers. For example, in Chitwan, we piloted this in Chitwan, and we're trying to do it in other places too. We give seedlings, bamboo seedlings, to farmers, and we tell them how to plant them, and they plant this bamboo along riverbanks. When they plant it along riverbanks, the benefit is it controls erosion. And riverbanks are usually marginal. They don't. It's not very fertile, so it's extra income for them. It's a wasteland, anyways. So, and also controls the erosion. And then we buy that bamboo from them at a fair price, like predetermined price. And then sometimes we even train them to do pre-processing of bamboo. For example, cutting, making strips. And then we bring it to our workshop in Chitwan, where we treat them, so it has long durability. And then we make bamboo furniture, or even bamboo housing elements. make trusses, we make trusses, we make houses, which I'll show. So we're trying to create an economy where everyone wins. You know, when you do this, you're reviving like old damaged landscape, and then creating good environment, which is exactly the opposite of what concrete and steel industry does. It's an extractive industry, where this is a regenerative industry. So we work with, so what do? We work with farmers. We do a lot of plantation. Last year we planted about 10,000 bamboo, and we want to do more. And then we document like all the traditional skills that are around, and we do research and development. You know, because unfortunately, even though we have so much bamboo, nobody is interested. There's no education system, you know, in university they don't teach bamboo, or, you know, so we do it by ourselves. And once we get to research and development, we design and build. And then we train a lot of people in the process. So there is an example. This is a land in 2011. There was a flood, and then it was a really nice farming land, and it brought all the stones and sand, and then it made it like unusable. What we did, we planted bamboo along, like on the same land, and 5 years later, it's become a bamboo forest. You know, so it's something that it's really fast. You can see the visibility, you know, and so we're planting it along the riverbanks. It's really controlled it, and we have extended this process with community in the river in Chitwan. And we planted it, and then what we do is we've used technology to we've created this mobile application where you can go to the farmer, and they will give you information. They'll tell you, okay, this is my coordinates. With a mobile phone, you can have a GPS, and says, okay, in my farm I have about 50 bamboo culms, and it's this species, and it's this age. So we have like whole documentation. So and then so this is like an example. Like for example, the reds are bamboo with less than 12 to 13 bamboo, and 17 to 18. So we're trying to put this all information online, so we can connect. People can connect to the farmers directly. And so we work with different partners on like promoting this. And, to go technically into bamboo, you know, bamboo is like tubes. You know, in modern engineering, tubes are considered it's the strongest material. But bamboo is like tubes, and they are composites of tubes, so they are even stronger. They're like lots of tubes connected, and so that's why it makes it really strong. It's flexible and strong. But one of the problems with bamboo is it has a lot of sugar content in it, because it needs all that sugar to grow fast. Yeah. So that's kind of the downside of bamboo, because of all the sugar, it gets attacked by beetle and termites really quickly. So you know, I was when I first started, I was going around and seeing all this beautiful bamboo. People know it's very strong. They know it's really beautiful, but they are not using it, and the reason is because of durability. So I was looking around, and there's a lot of expensive system to treat. So I was like, you know, I didn't have money, so I created modified this system where you have a bamboo, a chamber, a cylinder. It's connected to like tubes, and then it has a distribution on the other side, which connects to the ends of bamboo. And then you put the preservative in here, and then apply pressure. You can apply a manual pressure, and then it pushes the sugar content out of bamboo, like in like 5 minutes. You know, it's like really effective. If you see like on the other side, once you have this pressure pushing thing, the sugar starts to come out from the other end. You can see like it's all the sugar. After like an hour of treatment, and the sugar turns bitter because of it's replaced by the preservative, and it works. We exported our technology to Bhutan, and now they have in every community forest our treatment machine. And another success example was in Koshi, Bihar. There was a big flood, so we supplied these machines. And so this guy in the bicycle, he goes around to villages, he treats bamboo and he charges like 5 rupees for treatment. So it's created a really good social enterprise. This system works well, but the only drawback of this system is when you do this, the bamboo has to be green. Yeah? So that's not always possible, because when you take it out, and also it has to be within 12 hours. So by the time you bring the bamboo to your farm, it's already dry and you cannot use this technique. So we also have a system like a regular pressure chamber. This is in Chitwan, where you put all the bamboo and apply pressure and put the preservative in it, and it works. It's very effective. And this is a standard machine they use in the wood industry, and which we use here. Okay, now we have, the major problem was the durability of bamboo, which is now taken care of. The other problem is the strength. So how do we know, if you want to work with engineers, they always go what's the number, right? And since bamboo is a very heterogeneous material, it's like some are tapered, some are smaller, some are bigger. So it's kind of hard to do the tests because they will all come out with different results. So we created this non-destructive testing system where you apply load, and if it bends up to a certain point, it's okay, and if it goes beyond that, we don't use it, or we use it for something else. Yeah. So it's a work in progress. I mean, we created the system, but not actually been using it. And then we also created this joint system, to combine one bamboo with the other one. Here's a metal bracket, and we did a test in IOE in the same university, and then the test results were really impressive. Like, it feels like sometimes, like many in our tests, like the steel failed before the bamboo failed. It's so strong. The maximum load it could take was like 3.5 tons, which is more than what you need. Then we also work with different connection system. Some use steel for like more critical hard structure. We use steel for lighter structure. We use cane. We even use epoxy for furniture. When we do bicycles, we use cane. There's an experiment we did. We even bent bamboo. Instead of making joints, we thought like we could bend it while it's growing. So we did this. It's kind of successful. And then what we are doing is now working with Kathmandu University to make a lab, actual earth and bamboo material testing lab, where engineering students come and do all the tests. We want to inspire young engineers and architects to work with this material, so they know more, and so we get more data that can help in promotion of the material. And we're going more institutionally on this, but we've also, we want to make, in Nepal, there's a big gap between village level and between the academics and the artisans, the engineers. So, instead of relying too much on engineers, so what I've done is put like this small machine, like a UTM, to do all simple tests like compression tests and Onsite. So The boys can go there and like see if the joint is good or not. They use this machine and they'll go like, okay, it can take up to this load. I mean, they cannot interpret the thing, but at least they know, okay, this much load, it will fail. Also, we use this when we make bricks, so they can test it themselves. You know, our idea is to make technology more accessible to people. So we've created these joint systems, and we're building homes, and we're building. We use bamboo mostly for roof, because being a cold or hot climate in Nepal, we need thermal mass. People prefer thermal mass, and it's very hard to make that leap immediately from like other material to bamboo. But the roofs are relatively an easy sell. Like people accept this better because it's it's not a critical structure. I mean, it is a critical structure, but it's not something they touch every day. And it looks really nice, and it's lightweight. It has all the benefits. So before the earthquake, we're building like even if there's a house, concrete house, we'd have bamboo truss, which is this is test results in terms of how it behaves. We use this boron treatment for our bamboo, and the conclusion is like, when you use it, this is data from Hawaii, University of Hawaii. The conclusion was termite mortality was 100% using this technique. So the technique is really impressive. And for fire, it took twice as long as to ignite. It ignites, it takes a long time and created only 40% smoke and burned 1/3. It's more like it chars rather than burns. Yeah? So we've been using it for roofs. We're making like those walls could be anything. It could be stone wall, it could be earthen wall, it could be even concrete wall, and we use schools. My goal was to use it in public schools, because in Nepal the public schools are really uninspiring and boring. They're made with metal truss, CGI sheet, and then concrete blocks. It's dark, it's hot, or it's too cold, and it's not a good place to study. So we created this structure, like this. It was before the earthquake, and this structure was built in Gorkha, about 12 kilometers from the epicenter. Yeah. And it uses like stone. We have some bands and bamboo roof, clay tiles. Stone tiles. Everything locally available, and this survived the earthquake. Everything around for hundreds of kilometers around this village, everything collapsed in that area. But this building survived. So it was like a vindication of our technology. We felt, and after that we've been really promoting this. Before the earthquake, there's a lot of resistance to this material, but now, after this and a few other structures in urban areas that we built, the confidence has grown. And one of the biggest achievement so far was this public library, which is next door, literally. It's a public library, one of the biggest in terms of Nepali books, and it's made out of bamboo and earth. So, the perception has really changed, like before people were saying, oh, can you make me cow sheds or something with bamboo? And now they're saying, we can build like a public building out of bamboo. So there's a big shift in perception within a few years. And we feel very proud to have been in this process. So here's the inside of it. It's like a really complex roof truss using, and this is when it's finished, it looks really pretty. And then we're doing like multi-story buildings like this. We've also done like public spaces, our goal is to do a lot of public spaces, because housing, people know how to use bamboo, but we want to give something that can create big span structure, so we've been there doing, and we're making cafes, really trying to promote this material, so the stigma that it's only for poor people is eliminated. Yeah. So here's some examples of like houses, like this is a monastery that we did. Some of the details. So, and after the earthquake, we built this house with bamboo roof and earth wall. And we wanted, we want to give different technologies. Here's earthen wall, this is bamboo wall for kitchen to make it lightweight, and this is big thermal mass. And the idea was to show that you can build really beautiful house using locally available material without costing you arm and a leg. This is locally done, local labor, local everything. So we can provide dignified housing with local materials. So this is one example we did here. Another example we did in Bhutan, so as I said, my whole goal was to use bamboo in public schools, where we use public. So after the earthquake, we submitted a design for bamboo and earth structure for approval, which was luckily approved very fast by the government. We got that stamp, and we're building schools, which you visited. Our idea was to take the similar typology of government school, do not change too much in it, but use locally available material. So basic idea was to make there's 2 classrooms, separate them so it becomes multi-space, multi-function. In Nepal, people don't have shaded areas when it gets too hot. Either you have to be in classroom, which is dark. So we try to create this nice play space, and then classrooms, which we are building at this moment. And we are very aware of how it heats up, how it cools. And so this is a thermal diagram, trying to be very conscientious of heat. So this is, if you take the school and you separate it, the top part is bamboo, and the truss roof part. And because as I said earlier, you want something light on your head for earthquake reason. And then earthen walls for thermal mass. And then we have regular concrete foundation. We have beams at regular interval for earthquake safety. And the best part of this is, whatever labor cost you have, whatever the cost is, only 11% of the building cost goes in foreign materials, like cement and concrete. And most of the cost is in local materials and labor, which I think is a good cost because the money is staying in the community. So that's about it. Here's some reference we use for, you can go to all these codes. There's some, we use borrow things from New Zealand code, from Nepal building codes. So we're trying to create an economy, industry. The current industry gives out a lot of carbon dioxide, and the future industry of bamboo takes carbon dioxide and gives you oxygen. There's our website. Oh, actually, we have changed to. Let me. Sorry. I just recently changed our website. So if you go here, you'll find more information. about us. Thank you so much.